muscle communication and strength. I've made a few videos about increasing muscle strength by improving the muscle communication, but let's talk about the correlation between the two. Muscle strength isn't solely determined by the size of a muscle. We know that there are bodybuilders who are insanely strong and very large, but we've also seen individuals half their size moving the same amount of weight. So muscle strength doesn't necessarily equate to muscle size. But it's also determined by the strength of the communication between the muscle and the nervous system, the muscle and the brain, right? So muscle strength, will have to do a little bit with size. There is some correlation there. However, we also need to look at the communication between the muscle and the brain. This communication that we're talking about is the nervous system, obviously, plays a crucial role in how effectively muscles can be activated to produce force. So here, how muscle communication affects strength. Neural pathways and the signals, the back and forth, right, the communication, the information highways of the body. Muscle contracts, it receives the signal from the nervous system of the brain, spinal cord, to move. These signals, the electrical impulses, they travel down the spinal cord to the nerves that are connected to the muscles, and then basically tell it what to do. That's literally how it works. The brain says, do this, and then within unimaginable time, you're doing something, right? The nervous system can adapt to specific training by improving its ability to send and receive those messages. So that's really, really cool. And we'll talk a little bit more about that later. So basically, neural pathways and signals from the brain, nervous system, spinal cord to the muscle and back, right? We go back and forth. That's literally the communication. So what happens during that is motor unit recruitment and firing, right? Firing in a sense where basically if you ever started a cold engine, spark plugs have to fire, gasoline has to be burned, and poof, things kick over, right? In the human body, obviously, there's no fire in a sense, literal fire, but it does kick off and it starts moving. And you start burning, oxygen and all that stuff to get moving, or ATP, actually, or is that a byproduct? My biology science is old and I'm old. But motor units, they're basic fundamental units of a muscle contraction, right? They have motor neurons, muscle fibers. You also saw it, and if you watched my last video, I talk about the muscle spindle, which is part of the muscle, and it's part of this process as well. So the motor units are inside the muscle. They kick off action. Strength training can lead to improvements in how efficiently the nervous system recruits and activates motor units. So the stronger we are, the more communication we can get. So this means that the brain can activate more motor units at a time or activate them more frequently, leading to greater force production. So as it adapts, these motor units start getting better at their jobs, pretty much. And you either send more signals to recruit more motor units, or you activate them more frequently. So you either activate more motor units at a single time to generate force, or you send the signal more frequently to activate motor units to generate more force. That's cool. All right. Now, I talked about adaptations, right? There are neuromuscular adaptations. The nervous system can adapt to a stimulus, or in this particular case, a weight or a load, um, it could adapt actually and not in without improving, like a significantly changing the muscle size, right? I made a video a while ago talking about adaptations with just a simple 10-pound weight changes how the body can do a squat. There is a neural adaptation that happens, and the body adjusts to it. Uh, this is what we're talking about again. These adaptations can they improve coordination between muscles and the brain's and the body's ability to recruit these motor units that we were talking about before. And the firing order or the firing patterns of these motor units. Now, that is something that I'm probably going to have to make another video about, the firing order of muscle. This particular case, we're talking about the individual motor units, but we talk about muscles as a singular thing sometimes, and I think that's a conversation for a later date. So we're going to talk about firing order or muscle firing sequences later on, all right? But that all has to do with how the brain sends its message, right? And is it getting intercepted somewhere, or is it going somewhere first before it gets to where it needs to go? A couple of things can happen there. Yes, that is possible. So now, what are some examples of a neural adaptation other than the muscle frequency, the nervous system sending the signals more frequently, or sending more to recruit more motor units? Pretty much, we've seen where you can get strength gains in one muscle group that transfer to other muscle groups. So there is suggestion that neural adaptation is involved, because you get strength gains in one, the human body will now convert them to another muscle group in order to maintain homeostasis. It's called the cross-training effect. Never really studied this, so don't come from my head. So, but it is something that it's being researched and it's being mentioned, so I bring it to you. Specificity of training is another. Strength gains are often specific to the type of training performed, obviously. So indicating that the nervous system adapts to specific demands of the training. That's your basic fundamental idea of training itself, to get better at a certain movement or at a certain set of movements. So the body will get better at that, where you'll become faster, you become stronger, you become more flexible, you know, whatever the case may be. It's like you get better at it. The neural adaptation will be your body sends the appropriate amount of signals it needs, or the frequency increases, and you're doing the job better, right? And we all know that strength training is very, very important. It's becoming one of, if not the number one thing for most people to focus on over cardio, over straight up flexibility training. Strength training is what we need for longevity. So while muscle growth or hypertrophy is important for strength, neural adaptations are crucial for maximizing strength gains, particularly in the early stages of training. So if we can get it in the beginning, great. We're also going to need it later on when we're older, because we need to be able to recruit those muscles. Because not only is it good for that, it helps with balance, it helps with posture, and it helps with preventing injuries too. When we have a better muscle communication is improved, we can get improved strength, which will lead to better posture, less injuries, and better balance. Those are all great things. How do we do this? Higher load training seems to be the more appropriate style. You know, so heavier weights. I mean, not insanely world record weights, but heavier than you would think for yourself seems to be more effective at promoting a neural adaptation than lighter weights and low load training, pretty much. So summarize this. Strength is not just muscle size, but also how efficiently the nervous system can communicate with and activate the muscles to produce force. Neural adaptations like improved motor unit recruitment and improved signal transmission play a vital role in strength development. So we need to improve muscle communication to cause neural adaptations to improve overall muscle strength, and not just lift heavy things to get stronger. There we go. So strength is not just about muscle size, but also about how efficiently the nervous system can communicate with and activate the muscles to produce force. Improved muscle communication is the way we go.